Hey again. Hope you're enjoying all the little short videos I put out, but I realized on Instagram the time limit is very short on the shorts. So I'm going to put all these together in a bigger video. I realized I can edit on the phone there and put them together to make one video. So I hope you enjoy the video about structured water, and I will continue on the subject because we're just barely tapping into it. So thanks guys. Good morning. I'm going to try to do a series of short videos to condense a lot of information. I'll try to keep them under about 3 minutes or whatever to keep them as short. This one will be about the structure of water. Fix my collar. So water is oxygen, hydrogen, The ancients understood this stuff, and the Greeks knew this. They gave a proportion or a measurement to all of these angles and lengths in the water molecule that we call a water molecule. We'll get into that later. But my diagram's not perfect, but they would prescribe a measurement of 1 to 1 to 5 at the bottom. Now the ancients did not have numbers like we use numbers, they used letters. And the Greeks applied symbols to ratios. This ratio is known as phi. Which equals, if you remember from some old math class or whatever, try to forget all that stuff. Which is the ratio of 233 over 144. Let me make sure this is all on here. Okay, I got it. Now this is derived from the Fibonacci sequence, which I'll get into later. But basically, we're gonna write. Now, if we make a line the same length as this, which is 1, I don't know if this is right or not, and draw to the hypotenuse, what we have done is then created a new, smaller triangle, going a different direction actually, but that we can apply 1 to 1 to 5, okay? If we reapply this same thing by measuring off of this line, we have done the same thing, making a smaller yet triangle of the exact same proportions of the big triangle. This is the only triangle that can do this. All right, this one's going to be about the Fibonacci sequence and how phi is derived. So the Fibonacci, he was some Italian dude in the, I don't know, 800s or something. He came up with these numbers. But the ancients already had their own way of getting it. I'm not exactly sure how that works, but here's how the Fibonacci sequence works and is related to that. You start with the 1 and you add the number before it and make sure we're all, okay, we are. 1 plus nothing is 1. And again, 1 plus 1 is going to be 2. Then 2 plus 1 is 3. So on. I'm going to just go ahead and do this. 5, 8. Okay, I could go on forever, and they've actually developed, yeah, okay. They've actually made computer software and stuff to do this, but we only need to go actually this far, which is, check it out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. If we take the ratio of 233 over 144, that equals 1. Now, the cool thing and interesting thing about this all, once you've hit this point, 233 over 144, as you lead up to this point, if you say take 55 over 34, it will give you a number close to that, but not that close. It will be like 1.5 or something. Now, you can do this yourself. Go do it. 233 over 144 will give you 1.618. 377 over 233 will give you 1.618, and a bunch of digits after that, which, whatever. As you keep going down, it remains 1.618 throughout the entire sequence if you divide this number by this number, this number by this number. So that's how we got the phi. If we take a Fibonacci sequence and plot it out as like this being our 1, and so on all through the whole sequence, 1, 1, 2, 3, plot it out on a graph, this is what you're going to get. And in nature, you see this all over the place. So if we take that structure and apply it to this triangle of basically infinite, what happens is infinite commensurability. This basically fractalizes down infinitely and will open up infinitely as well. So it is said that water has memory. And I believe when you combine waters and salts, which are this form, and we'll get into that some other time, but there's some important stuff to be learned by all this. Peace. All right, so we've basically established that there are patterns in nature, and the water molecule in the Fibonacci sequence that is seen in nature. You've seen it in conch shells and the way plants grow and things of that nature. There's an interrelatedness between the two. Now I'm going to go to something a little different, but not so much. Let me see where I'm at in here. Okay. This here is like a tornado, a torre. If we continue it out in its complete path, and add a big field around the toroidal field here. You can even, well, we won't do this. We'll call it anode and cathode. These switch. This is the system of everything. So the earth has this, the sun has this field of energy. These are frequencies. Yeah, light, sound, everything can be seen as this red, infrared, and you get into the ultraviolet stuff up outside of our spectrums. But the Earth's frequency is known as the Schumann resonance. Man, I don't know how to spell that. Schumann resonance, frequency, Schumann resonance. Look that up. It is a pulse that the Earth has. So when the water enters down into the Earth, it's going to get nurtured by this Schumann resonance. And surface water does not have this, okay? Surface water that comes out of your rivers and streams, this is tap water. That is what they plumb into the lines. Of course, they filter it or whatever, but water holds memory due to its structure, which I showed the structure of water a little bit ago. I'm gonna edit this all into one video. Hopefully we're under 3 minutes. Peace.